Welcome to the MS SQL Tips webcast, Building Clusters to Protect SQL Server in the Cloud, sponsored by SIOS. I'm Greg Robidoux, co-founder of MS SQL Tips and the host for today's webcast. Our speaker today is Dave Birmingham, who is a high availability expert and Microsoft Cloud and Data Center Management MVP. And today he will discuss things you need to know to protect SQL Server in the cloud. During the webcast, we encourage you to ask questions. To ask a question, enter your question in the question area in your presentation controls, and we'll try to answer as many questions as possible during today's webcast. In addition to today's event, we invite you to check out all of the free resources on mssqltips.com. If you're not already a member of the community, we invite you to join. You can go to www.mssqltips.com, sign up for our newsletter, read any of our tips, download white papers, and watch on-demand videos. This webcast will be recorded and archived for future playback, and you'll receive a follow-up email with links after today's event. So at this time, I'm going to turn things over to Dave, and he can get started.
Great, thanks, Greg. So as Greg mentioned, my name is Dave Birmingham. I am a cluster MVP and cloud and data center MVP most recently. I have a blog called clusteringformeremortals.com, and I worked for SIOS Technology for the past 13 years now. I just celebrated 13 years in February, where at SIOS I've been given the ability to focus exclusively on high availability and disaster recovery solutions for Windows and Linux over the past 13 years. So it kind of gives me that laser focus on high availability in that topic. And most recently, cloud is big. What we're seeing a lot of customers moving to the cloud. So cloud and high availability and SQL Server are really kind of my three specialties at the moment. So the agenda for today, we're going to take a look at the cloud and what the cloud guarantees with their service level agreement. We're going to look at Azure and AWS as examples. Most clouds have similar agreements and similar features and functionality, but these are the two kind of biggest players out there at the moment that we're going to kind of reference when we start looking at architectures and other things. We look at the potential points of failure in the cloud, and then we're going to look at the SQL Server high availability options, which includes the always-on failover clusters and always-on availability groups. We're going to kind of compare and contrast the two solutions. And then we're going to look at cloud infrastructure, talk about the different features of Azure and AWS, which are going to help you build highly available SQL Server. And then we're going to take a moment to tell you a little bit about SIOS Technology, the sponsor of today's presentation. Okay, so let's jump right in. So the cloud service level agreements. If you look at the Azure's SLA, at the high level, you'll see they're saying we get 99.95% uptime guarantee, which equates to about 22 minutes of downtime per month, which is within their allowable allotment. Anything above and beyond that, then you can apply for some sort of reimbursement. But then you have to read the fine print, and in order to qualify for that service level agreement, you have to have 2 or more instances in what Microsoft calls an availability set. We'll take a closer look at that in a moment. But even if those instances are in an availability set, Microsoft's really only guaranteeing what I call dial tone to that instance. So it's something that the instance itself is reachable, but it doesn't guarantee that the application is actually up and running. The other thing it doesn't guarantee is that the additional storage attached to that instance is fully functional. So they have a different SLA for storage, and if you look at the SLA and you read through all the different guarantees, and there's different levels of SLA depending on what you have, local redundant or geo redundant. But when it comes down to it, the weakest link in the chain is the write guarantee. And the best that they can guarantee for write is about 99.9%, which equates to about 44 minutes of downtime per month. And obviously SQL Server, to be considered highly available, obviously you need to write to the ability to write that storage. So you're really only getting a guarantee of about 99.9% for that. And again, that does not account for what's ever running inside that virtual machine. So if you're running SQL Server and you need to ensure SQL Server is up and running, you have to manage that yourself. You got to make sure SQL Server is up and running. And so we're going to leverage traditional Microsoft technologies for monitoring and recovering SQL Server. Similarly, over in AWS, they have their own service level agreement, and I copied this right from their documentation. We'll talk about region unavailability. It's very similar to Microsoft that they guarantee that at least one of the availability zones in the region is going to be available to you. And if you have a failure of more than one availability zone, that could account that that could apply towards your downtime. And they don't have a different SLA for the EBS storage versus the EC2 instances. So their SLA is say 99.95% across the board. So similar, but you have to read the fine print, and same with any cloud provider. You're going to really have to understand what the SLA guarantees and what you must do to actually meet and qualify for that. So assuming you're moving to the cloud, or you are thinking about moving to the cloud, you're going to have to look at your potential points of failure, and they're going to be different than you're used to on-prem. So let's take a look at that. So this is a picture. This kind of represents Azure, but very similar to any cloud instance. Where at a whole, the cloud is a different beast, and so you have to think of it, at different layers. So, of course, the cloud itself. What happens if there's an outage? And now we've seen both Azure and Amazon have outages, major outages, which cross multiple regions and availability zones. And typically those outages are due to human error. And the past two major ones from both of those vendors have been human error related. So what happens if someone does something really stupid and brings down the entire Azure stack, the virtual machine service, and so nothing's running? Same with AWS. What's your plan? If your plan is to call Microsoft and complain about the outage, that's one plan, but that's really not an acceptable plan if you need to ensure that your service is going to be highly available. So take a look at maybe crossing cloud providers as an option. You can leverage, if you're primarily running in Azure, you can think about having an instance running in AWS and leverage the technologies we're going to talk about, whether always on or some replication solutions to move your data out of the cloud to another location that would be insulated from that type of outage. And of course, anything in the cloud is very dependent upon internet access. So you're going to have to ensure that you have redundancy wherever possible, depending on how you leverage the cloud, whether you have clients connecting remotely from from just a public internet, or you have VPN tunnels, or you have direct connections into the cloud. You have to plan for that redundancy at that internet access level. Then within a geographic region, there's some features and functionality each cloud provider enables. In the Microsoft Azure world, they have something called an availability set, and we'll take a look at this closer in the next slide. But it gives you the ability to have some redundancy within a region so that your instances aren't running on the same physical servers, or relying on the same power supply or networking stack. So you have to make sure you take advantage of whatever your cloud provider is providing for that redundancy within the geographic region. But then within the VM itself, you have other possible single points of failure. So the storage, and we talked about the storage, having a different SLA in Azure. So you need to do what you can to ensure that your storage is highly available. I know Azure recently announced a new feature called Managed Disk, which gives you even a higher level of availability in theory than you did prior to leveraging Managed Disk. And in a nutshell, what Managed Disk can do, if you are leveraging the availability set, it can ensure that the storage attached to one instance runs on a different physical storage cluster than the storage attached to your second instance. And before that managed disk, there was really no way to guarantee that the storage attached to each instance was not provisioned from the same storage cluster. And so it just gives you a little bit more redundancy. And cloud providers are constantly making improvements like that to help ensure the availability of your storage. The SQL services I've mentioned before, you have to manage that independently in Microsoft or Azure or AWS, or they're not going to guarantee anything about the application. So you, as the administrator, need to take steps to ensure your application is up and running. So we're going to leverage failover clustering and availability groups in the SQL Server world to monitor SQL Server services and take recovery actions should you have a failure of one of those services. But beyond that, Microsoft failover clustering, which is required for both of those solutions we just mentioned, the always-on availability groups or failover clustering, is very dependent upon Active Directory. So you have to ensure your Active Directory is highly available, DNS is highly available. There's some services, there's Active Directory Azure service that you could use, or if you're going to manage it yourself, just like on-prem, you have to have redundant domain controllers. And those domain controllers, as you'll see in a moment, should be also an availability set to ensure that they're distributed across the region in different areas for high availability as well. And then in the networking stack, and I've seen this cause outage more often than not, where someone goes in and changes a firewall setting. And so the cloud has a whole other, firewall configuration that there's many different levels of configuring a firewall. So someone accidentally updates the network security group in Azure, and all of a sudden blocks a port that is very important to your cluster. For instance, in Azure, there's a port 59999, which is a probe port that the load balancer uses to determine which node is online. If someone doesn't recognize that port and they see that port as being open and available, they might think, well, I better close that up. I don't even know what that's for, because they're not aware of what's required. That could very well shoot you in the foot as well. So there's lots of potential points of failure that you need to be aware of, and you need to make sure your team, everyone involved in your team, is up to speed on how you're providing availability for your services. So again, going into SQL Server itself, now other applications like your web servers or your application tier might be as simply deploying multiple web servers and putting them behind a load balancer and distributing those web servers across different availability zones or fault domains, or even across different regions. And that's the end of the story. That's all you need to do, and you can spin up more or less depending upon the workload. And that's the beauty of the cloud, is it enables you to scale up quickly for busy times and scale down for less busy times to save money. But when it comes to SQL Server, it's not that easy. You can't just spin up multiple SQL Server instances and put a load balancer in front of them and expect everything to work properly. You need to have additional configuration, again, including the options of the failover clustering or the always-on availability groups. So let's talk a little bit about those options. Always-on availability groups was introduced in SQL Server 2012 Enterprise Edition. I really think of it kind of an evolution of what was available before the SQL Server database mirroring, and it allows you to replicate user-defined databases and detect failures of the physical server, or with the most recent version, you can detect failures of the databases and initiate failover of that database from one physical server to another physical server, or in the cloud from one cloud instance to another cloud instance. It also allows you to group like databases together to ensure that they move as a group. And that was a limitation of database mirroring. You couldn't ever ensure that those databases moved together. So that was introduced in 2012 Enterprise Edition, and continues to be improved upon in later versions. What I call SANless failover clustering. So when you talk about the cloud, everyone's familiar, or most people are familiar with a traditional failover cluster. And it's been around in Microsoft and been providing high availability for SQL Server long before availability groups was ever available. The only issue with the traditional failover cluster is it requires a shared disk, some sort of SAN that supports SCSI-3 reservations, so that all your database files reside in a single location, and depending upon which node is online, that node has access to that shared storage location. In the cloud, there is no SAN for you to leverage to build a failover cluster. So we have to build something called a SANless failover cluster. And SANless failover cluster basically leverages, in 2012 or 2008 R2, you have to look at third-party solutions, such as the one we're going to talk about at the end, the DataKeeper Cluster Edition solution. In Windows 2016, you also have the DataKeeper solution. There's a new solution called Storage Spaces Direct, which is a feature in Windows 2016 Data Center Edition, which can allow you to build a scale-out file server that spans instances that you can also leverage. So that's a possibility with Windows Server 2016. But what the SANless clustering does is it allows you to build the traditional failover cluster that you might be used to on-prem, and just take that same configuration and move it into the cloud. So it gives you the same high availability and data protection that you're used to on-prem. And one of the driving factors for this that I see are people looking to avoid the high cost of the SQL Server Enterprise Edition. So the failover clustering supports a 2-node failover cluster with SQL Server Standard Edition. So that's another good reason for using failover clustering in that SANless configuration in the cloud. So we look at these two solutions side by side. This is a chart that I like to use that shows some of the features, obviously with SANless clustering on the last column, having all of these features, and the availability groups lacking in some of these features. And so again, support for SQL Server Standard Edition is not in always on availability groups prior to 2016. Distributed transactions are not supported. There's a limited number of databases that you can use with the availability groups. The availability groups does not protect your system databases, so all your agent jobs, your logins, passwords need to be managed separately. And every time you add or drop a database, you have to reconfigure your availability. So there's additional administration overhead with the availability groups, and you're limited to a 2-node in the failover configuration with this, SQL 2014 and earlier. And then if you're looking to replicate other data besides SQL, well, you're out of luck. The availability group is only a solution for SQL Server itself, whereas in the SANless cluster solution addresses all those limitations. Now, SQL 2016 did add some features which made some improvements. So in the Standard Edition, they have a basic availability group which allows you to protect a single database in a single availability group, similar to what you had for many years in database mirroring. So there's limitations there. It's only usable in small environments. There is some limited support for distributed transactions, but you have to really read the fine print. Distributed transactions are still not supported between transactions, between databases within the same SQL Server instance. So it's only supported when the transactions are distributed across multiple SQL Server instances. And they have now added the ability to have failover configurations in 3 nodes. So that's been improved upon as well. So we're going to take a moment here to take a quick poll, and Greg's going to pop up a question if you just a moment to answer. Just curious to what you're currently using for high availability for SQL Server. whether it's on-prem or in the cloud.
All right, the poll's been launched, so just give everybody a few seconds to answer this, and then I'll read off the results once we get the votes in.
All right.
I've got a good amount of votes already. Let me just give us another 10, 15 seconds, and then we'll tally the votes and display them. All right, let me close that and share that. So we have 63% SQL failover cluster instances, 37% SQL always on availability groups, 17% for other, and 16% for none.
Great. Well, yeah, it kind of confirms what I see. Failover clustering is still the primary high availability solution with always on. When enterprise is available, always on can be a decent solution for you. So it's great. So we're going to jump into looking a little bit closer at the cloud infrastructure of both AWS and Azure and talk about that a little bit. So in Azure, I mentioned earlier, to qualify for their service level agreement, you have to put your instances in an availability set, and by putting your instances in an availability set, what it does, it ensures that those instances in that availability set are distributed across what Microsoft calls fault domains and update domains. So fault domains you can think of as independent racks of servers that don't share power, that don't share networking, and so there should be no single point of failure that would impact more than one fault domain at any given time. And the update domain you can think of as those individual servers within that rack. And what Microsoft guarantees is that for planned maintenance, they will only work on one update domain at a given time. So in this case, we put our 2 SQL Server instances plus our file share witness, which we'll talk about in a moment, in the same availability set. It will automatically distribute it across 3 fault domains and 3 update domains. Now there's a limit in Azure. The most you can have is 3 fault domains. Now when it comes to update domains, you can distribute it across multiple update domains. I think out the gate it's like 20, but I believe you can request that to be increased to even have more update domains. And that would be advisable if you have a very large web farm. You'd probably want each web server running on a different physical server so that, if they update one physical server, they're only going to bring down one of your web servers. So we talked about domain controllers as well. So redundancy for your domain controllers, if you're managing it yourself, they would also go in an availability set and to ensure that they're running on different fault domains. And the web tier as well, all those will go in separate availability sets to ensure they're distributed and you have availability across all the tiers of your application. And this is a picture of what your configuration might look like if you're running in Azure, in the West region, and you configured it like I showed you earlier, where you have 2 SQL Server instances and a file share witness in the same availability set. It will ensure that each instance is in a different availability set. And the file share witness, if you're not familiar with failover clustering, there's a concept of a quorum which essentially decides which node comes online should there be a failure. And the quorum, in order to function properly, always needs a majority of votes. So in a 2-node configuration, if you lost one node and you had one node remaining, 1 out of 2 is not a majority. So it breaks the tie by asking a 3rd node to also vote in the cluster. And in the cloud, you're going to leverage a file share witness if it's Windows Server 2012 R2 or 2008 R2. In Windows Server 2016, they introduced something called a cloud witness, which eliminates the need to run another server for file share witness and allows you to leverage Azure Blob Storage to act as that vote. That's a new feature in 2016. But it looks like that, and so there should be a failure of SQL 1, SQL 2, and the file share witness will form the quorum and bring things online on SQL 2. It's a simple picture of a 2-node cluster in a single region in Azure. Now we talked about, how do we protect against a cloud outage? Should, entire Azure go offline, or entire East Coast region of Azure? Maybe a natural disaster could totally impact all your fault domains in a single region. So you have to look at getting your data off-site to a different location or a different cloud provider, and you could do that by leveraging the replication technology of the always-on availability groups with the asynchronous replication, or with DataKeeper Cluster Edition would also allow you to do asynchronous replication. I mentioned the storage spaces direct in Windows Server 2016. As of today, there is no ability to do asynchronous replication to a third node, so that would be a limitation of the S2D solution. So if you're looking for the complete high availability for local failover and remote replication to a third node off-site, you're going to have to look at the always-on solution or the DataKeeper solution to give you protection of the local failures as well as the disaster recovery. So what Microsoft does is something called Azure Region Pair. So I mentioned earlier that within the same region, there's something called an update domain that Microsoft will only update one update domain or one little physical server at a time for planned maintenance. So that ensures that, if you configure everything properly, you shouldn't have any downtime for planned maintenance. Now, if you're going to replicate between regions, you can also be sure that Microsoft would only do planned maintenance in one region at a time, assuming that you have your instances deployed in what we call region pairs. So for best, the best high availability, you have to know what your region pair is. So if you're deploying virtual machines using East US, right? You probably want to leverage West US as your DR site, because they will never work on East US and West US at the same time. So if there is some sort of, human error that happens that impacts an entire region during an update, hopefully it's limited to just that region, the West US should be totally unaffected, and so you can start running over there in West US. Same with US East 2. If your primary data center is East US 2, then your DR site should probably be Central US to guarantee that you shouldn't have an outage of both of those regions at the same time. Now, if you chose and you didn't know about these region pairs, and maybe you're running in East US 2 and your DR site is West US, well, Microsoft very well could be updating East US 2 and West US at the same time, and so you could have an outage of both regions. So you want to become familiar with this, and this is an Azure specific feature. I haven't seen or heard of a similar feature in AWS. If I've missed it, someone let me know, but I don't think there's anything similar in AWS in terms of planned maintenance like that. In AWS, similar to Azure, it's going to look very similar to the picture we saw earlier. They have different terminology. So they have availability zones in Azure. So you're going to have, availability zones in AWS. So you're going to have SQL 1 in availability zone 1, that could fail over to availability zone 2, and then your file share witness should run in availability zone 3. And so you have to look at your region to make sure that you have at least 3 availability zones available. Or you can leverage the Cloud Witness, even though this is AWS, you could leverage the Azure blob storage account for Cloud Witness. So that's also a possibility. Okay, so let's jump to the second poll question. I'm curious to know what platform you currently use, what cloud platform you currently use or are planning to use. So we'll go ahead, Greg, and put up that question.
All right, the poll is launched, and we've got a good amount of votes in already. All right, another 10 seconds, and then we'll share these results. All right, I'm going to close that and share the results. So we have 40% Microsoft Azure, 32% AWS, 31% none, 6% other, and 1% Google.
All right. Well, that's about what I'm seeing out there. Google is relatively new to the game with their Google Compute, and I've been doing some work with them, so that I expect to see that percentage maybe inching up a little bit, but good to know. All right, so I could do a whole half-day seminar on Azure high availability, configuring it, and same with AWS. I'm not going to go into some, all the nitty-gritty details. Essentially the technology is the same if you're familiar with failover clustering. If you're familiar with always-on availability groups, it's pretty much the same, but there are certainly some things you need to know, especially around networking to get things working properly. But the good news is, and with the cloud, is that there are options to automate these procedures. So just jumped out to my web browser to give you a picture of some things you can look at to help automate this, automate your deployment so that it takes the struggle out of actually building these by hand. So in AWS, there's something called Quick Start. So I opened up the launching pad for the SQL Server on AWS Quick Start. You look at the picture, I know it's kind of small, but essentially, if you click on this little button that says Deploy on AWS into a new virtual private cloud, it will configure the entire thing for you, soup to nuts. It will, including domain controllers, all your virtual private clouds, all your virtual networking, your SQL Server instances, even your availability set with a sample database, and take care of everything for you. So it's very simple to do that. If you have an existing virtual private cloud, an existing network, and existing domain that you want these instances to join, well, there's another link here, deploy into an existing virtual private cloud. So this is the future. Every time you need to deploy, a SQL Server instance, you don't want to have to go and launch through 2 servers, install SQL Server, configure clustering, fix all the networking, load balancers, everything that's involved with that. You really want that automated deployment process so that it's very easy, repeatable, and eliminates human error with that. So that's available on Amazon. So you're going to definitely want to check out that. There's new quick starts being published all the time, so keep your eyes open for announcements around that. In the Microsoft world, there's a couple options. There's the Marketplace, which is, in Azure Marketplace, allows you to launch some things. There are some options within the Marketplace, but the real power in Azure is around Resource Manager and deployment templates So anyone can create a GitHub account. If you're not familiar with GitHub, you're going to want to become familiar with this. But GitHub, you can leverage Azure deployment templates and basically automate anything you want. And this particular template I'm looking at is, for SIOS Datakeeper SQL cluster, and the description here, it basically creates a 2-node SQL Server 2014 cluster. It does domain controller and some client VM. So it's a great way to kick the tires in Azure and without having to spend a whole lot of time configuring things. So similar to AWS, you can go over and click the button that says Deploy to Azure, and that will launch you right into the Azure the Azure portal. If I log in here, it should come up, and you'll see once you're here, it's basically ask you a couple questions. And one thing would be like, your domain, what user account, password you want to use, and administrator account name, pass a license key for the Datakeeper software. So you see there's some fields here. You can use existing resource groups, create a new resource group. You can choose the size of the instance. So if you're familiar in Azure, there's different sizes of virtual machines, which gives you more CPUs, more RAM, better IOPS, and so forth. So you just choose a couple configuration options and then click Agree to the terms and conditions and click Purchase. And I'm not going to do this, but if you click Purchase, come back about an hour later, and you're going to have your 2-node failover cluster already configured for you, ready for you to start kicking the tires. So again, that's going to make things easy for you. But there's also, obviously, there's how-to articles, especially in my blog I mentioned earlier, Clustering for Mere Mortals. I have a lot of step-by-step instructions on deploying failover clustering in the cloud. So you're going to want to definitely check that out. So with that, I'm going to jump into a quick overview of the SIOS Datakeeper solution I've mentioned earlier. And so traditional failover clustering, I mentioned, been around for quite some time, 2 or more nodes connected to some sort of shared storage device. And in the cloud, there is no shared storage device available. So you're not going to be able to build a traditional shared storage failover cluster. Instead, I'm going to use what we call the SANless cluster, which allows you to leverage local attached storage and still have a failover clustering. So essentially, in the cloud, you're going to have additional storage attached. So if we were talking Azure, you're going to attach some disk. It could be standard disk, it could be premium storage, it could even be a storage space with multiple premium disk in a simple pool, which is going to pull together your IOPS to give you an incredible amount of IOPS. I think the most IOPS you can get is going to be on like a GS5 instance. It's going to give you 80,000 IOPS, and that would require a P30 disk gives you 5,000 IOPS, so you would need 16 P30 disks, which are a terabyte in size, in a single storage pool with simple parity, which is basically RAID 0, and that will give you 80,000 IOPS. And I've tested that, and you certainly will get 80,000 IOPS. You're going to spend some money for that because premium storage is not inexpensive, but if you need that sort of IOPS, you can get that. Same with Azure, AWS. There's disks that are provisioned IOPS, so you really have to think about what you're looking for. But you're going to just attach that storage, and then the SIOS solution called Datakeeper is going to replicate that storage between the different instances and integrate with failover clustering through a Datakeeper volume resource, which emulates a physical disk resource. So it kind of looks, feels, smells like a shared storage device, but instead of controlling SCSI reservations, it controls the mirror direction. And that works with SQL Server, but it works with any cluster workload. So if you want to build a file server cluster We do a lot of work with SAP in the cloud because to deploy highly available SAP traditionally requires a Windows Server failover cluster. And so we can allow people to build SAP deployments in the cloud. So that kind of looks like this. Again, you have 2 or more nodes with local attached storage, and we're just going to do the replication either synchronously between regions, between instances in the same region, or again, if you want to replicate outside of a region to another region or even to a different cloud provider, you would leverage asynchronous replication, which is going to allow you to replicate greater distances over higher latency links. And it works the same as your traditional shared storage cluster, because it really is a failover cluster instance that's just leveraging a different type of storage. Again, it works with any traditional cluster workloads, so file servers as well, and that works just fine. Picture we saw earlier where you might have a failover locally for HA and then replicate to a third site for DR. You can do that as well. Now, some people are looking at the cloud as a potential disaster recovery site, and that's a great use case for the cloud. And so you might have an existing shared storage cluster on-prem that works just fine, you're happy with, but you're looking to leverage the cloud. Now, traditionally you might talk to your SAN vendor and say, well, EMC, I want to replicate my my array to the cloud. And if you had your own data center, you might put up another EMC SAN and use SRDF or something. Most storage vendors will have some sort of array-based replication solution that will work fine from from between arrays in the same family of arrays. But in the cloud, you don't have access to the storage, and so you're not going to be able to leverage the array-based replication solutions. Our solution is storage agnostic, so you can replicate between any local storage and any storage in the cloud, and have a very robust disaster recovery solution without having to build out your own data center. Again, picture we saw earlier, this is just similar AWS and Azure. You're just going to leverage the infrastructure that each cloud provider enables, from availability zones to fault domains, and you're going to have a failover clustering solution available to you. So the most exciting announcement recently from Microsoft around SQL Server is the ability to run SQL Server on Linux. So if you're a Linux shop and you're considering alternatives to Oracle or MySQL, and SQL Server might be a enticing solution, especially now that it can run on Linux. But you still need to ensure the high availability of that solution. And so SIOS has high availability solutions for Windows and Linux, and we've been doing high availability on Linux for longer than anyone. So even the solution even predates the company SIOS Technology, founded back in 1999. They've been providing HA solutions on Linux. So we have a product called the Protection Suite. It includes a high availability solution called LifeKeeper, and it also includes the replication solution. We've been talking about DataKeeper, and so we can enable you to build SAN-less Linux clusters as well. So again, we've been doing this for a long time for traditional SQL Server, MySQL, SAP, just basic file services. We've gone through the process and tested and verified that we can also build protection for SQL Server running on Linux. So that's a great solution if you're interested in that. Definitely want to talk to us about that. There's an article published on linuxclustering.net that goes through the whole process, step by step, telling you how to build a failover cluster of SQL Server running on Linux in Azure. And this is a simple picture here, but that's all documented and tested. So that's another solution from SIOS Technology. I mentioned, we have lots of customers. One of our larger companies, a large software company, they had a requirement to move SAP from internal into Azure, and they were able to leverage our solution to migrate their SAP environment. First, they went from physical servers to Hyper-V, and then moved into Azure. And one of the requirements was it had to be SAP certified and Microsoft certified, Azure certified. So the solution met all those requirements. So they were able to build that 2-node failover cluster for SAP in the Azure cloud. Another company, Zespri, the world's largest marketer of kiwi fruit, they were able to leverage the DataKeeper solution to move not only their SAP workload into the cloud, but also their SQL Server infrastructure into the cloud. Similar requirements, SAP certified, Windows certified, Azure certified, and they moved test, dev, and production all into the cloud, and are leveraging the DataKeeper solution for high availability of that solution. So to kind of sum it up, the SIOS SAN cluster solution helps you to meet your demands as we see people moving more from on-prem, physical, virtual infrastructure into the cloud instances. They're looking to, a lot of people, they don't want to change the way they've been doing things. So they have this kind of lift and shift mentality. It's like, I have a failover cluster on-prem, I want to do that in cloud. I don't want to look at always-on availability groups. I don't want the additional costs associated, or I don't want the re-architecture of my application. I just want things to run the way they've been running for years. And so they are able to, we're able to help them do that with the DataKeeper solution while moving into the cloud, which eliminates all the costs associated with re-architecting things. There are also some benefits for people that are just moving in, into VMware and looking to provide high availability. We can allow VMware customers to build failover cluster instances between guests without requiring raw device mapping, which if you are familiar with VMware and clustering, for the longest time you had to use raw device mapping, which broke all the VMware features and functionality like vMotion, VMware HA, and snapshots. So by leveraging our solution, they can have high availability and still take advantage of their VMware HA solutions. So with that, I'm going to open the open it up for questions and answers for the last portion of this webinar. My contact information is here. Should you have any questions, feel free. Tweet, call, email, whatever, however you like to communicate, and we'll definitely be able to answer any questions you might have. But we have about a little more than 10 minutes here, so I believe, Greg, we have some questions already in the chat.
Yep. So there are some questions. Okay. Yeah. So if you have some questions, and anybody else has questions, feel free to use the questionnaire. Just type them in, and we'll take them one at a time. So one question is related to on-premises having a cluster, and some of the advantages there they say is for patching. So is that a good reason to move the cluster to the cloud as well, to have two servers so one's always available and you can patch the other and flip back and forth?
Yeah, definitely. Failover clustering eliminates unplanned downtime, but also minimizes the planned downtime, as you mentioned. If you only have a single server and you need to do maintenance, well, that server is offline and there's nothing you can do about it. If you have to reboot the server or whatever, you're going to have downtime. With a cluster, you can do what's called rolling upgrade, where you can update the passive node first, so you're not impacting the availability of the application, and then do a failover to that node and then patch the other node. And so you minimize the downtimes. The failover time is measured, typically in seconds. So you might have a little blip interruption of the service, but you're going to be able to have a much higher level of availability even for that planned maintenance. And
Okay.
so that same thing applies in the cloud.
Okay. And that applies for both patching Windows and patching SQL Server?
Yes.
Okay. All right. The next question here is just related to just what SQL Azure is based on, and I'm not sure if you know the answer to this or not, but I'll throw it out there anyway. So I'm just wondering, are all the features of Azure pretty much based on SQL Server 2016? Are there some features in Azure that don't exist in the on-premises? Do you know the answer to that?
Well, I can kind of read between the lines. So when you talk about running SQL Server in Azure, you have, or any cloud provider typically, you have two options. You have infrastructure as a service, and you have software as a service. And so what I've been talking about today is infrastructure as a service, and that's where you are managing virtual machines, and you're managing SQL Server. And so you're essentially, it's your own data center in the cloud. You're going to spin up Windows, you're going to join domains, you're going to install SQL, you're going to create clusters, and it has this full feature set, that the same feature set that you have on-prem, you have in the cloud. That's great because it's going to work just like you have on-prem today. Now the alternative is software as a service, which essentially Microsoft will manage a SQL Server instance and give you a slice of that instance and allow you to have a lot of the same features and functionality, but not all the same features and functionality. And so whether that is based upon SQL 2016 or 2014, I imagine it's probably based on 2016. I don't know that for sure, but it is a subset of functionality. And so if you're looking to move to the cloud and you have an existing application and you have SQL Server supporting multiple applications, you're going to have to verify each application will actually coexist with the software as a service that Microsoft provides. There's probably going to be some rework required, and so it's going to take some time to verify whether or not you can use that. And if you use software as a service, I guess one of the benefits are that it takes the management out of your hands. So you don't, if you're using software as a service, you don't have to really manage the availability. Microsoft is basically saying, trust me, I got this. I'm going to make sure this service is highly available for you. And then so there's nothing on your end that you need to do to provide high availability. Now, of course, that goes back to, well, what happens? What if there is a major outage and that whole service goes offline? If you don't have any plan in place, for that day, the best you can do is call Microsoft and complain and apologize to your customers. So you're going to have to look into software as a service, and I'm not as familiar with what people do that are leveraging software as a service, but you're going to want to try to get a copy of your data minimally out of that service on a regular basis so that you have a kind of worst case scenario. If I had to put things back together, well, at least I have a relatively up-to-date copy of that data. And whether you can leverage log shipping or database mirroring or other technology, I don't know off the top of my head what you can do for that, but you certainly should look into that if you're thinking about software as a service, so that in that worst case scenario you have an option.
Okay, the next question, Dave, is related to the failover process, and I guess it's just clusters in general. They're just wondering, when there's a failover, what happens to uncommitted transactions?
Yeah, just like a shared storage cluster today, if someone pulls the power cord on the active server in the middle of a transaction, when the passive node comes online, SQL Server Services startup, it looks at the log file, looks at the data file, and uncommitted transactions are rolled back. So you'll see SQL Server will log an event that says a soft recovery is occurring, and those uncommitted transactions will be rolled back before that database is mounted.
All right, the next question is related to the GitHub template that you mentioned, or you showed us. So someone's just wondering if you can, so basically running it, there's basically just a button they can click on. Is that the case?
Mm-hmm.
And then secondly, they're just
Yeah.
wondering, is it possible to modify that template before it's actually launched, or is that kind of hard-coded?
Yeah, I mean it's open source, so you see all you can have the template and modify it for your own particular use case. So you know you can get into the JSON code and do whatever you want with it. So a lot of these templates are put together from bits and pieces that Microsoft has published already. So you can leverage you know bits and pieces of different templates to do what you know your own template. And so that's certainly a possibility, you know, for people that don't want to get their hands dirty or familiar with JSON, they're not programmers, it's just scary. You know, the only modification you can do is what is exposed in the parameters I showed you. So picking different instance sizes, picking what region you're going to deploy in, picking what resource group you might deploy in, and so forth. So, it's much less control, but, they're the basically two ways you can, kind of manage the deployment.
All right, the next question, Dave, is related to always-on availability groups, and they're just wondering, doesn't always-on availability groups already allow for direct attached storage? And they're just wondering, what's the advantage of, SAMless cluster over always-on availability groups?
Yeah, always-on availability groups does leverage direct attached storage, and in terms of DataKeeper, it is our biggest competitor, and so we compete in a couple different ways. Price is certainly one consideration where people look at the cost of SQL Server Enterprise Edition and compare that to the cost of SQL Server Standard Edition plus DataKeeper software, and they're going to save a significant amount of money, and if the only reason they were buying the Enterprise Edition in the first place is for availability, they many times will choose to go with Standard Edition and DataKeeper and give them very, very robust HA and disaster recovery solution. There are some technical reasons that I kind of tried to illustrate in this slide earlier. Support for distributed transactions is very limited with availability groups. It also does not replicate the entire instance, so all your agent jobs, logins, and passwords, none of that is replicated and fails over when you talk about availability groups. It's only user-defined databases. And then just the management of that, you have to manage each database individually. As you add and drop databases, you need to account for that. The overhead associated with availability groups, as you add additional databases, as you add different more availability groups, you consume more worker thread processes. So at some point, you're going to run out of resources. If you're trying to deploy a lot of databases, you're going to find that you're going to run into a bottleneck at some point, and where it's not going to make sense any longer to use availability groups. Whereas with the DataKeeper solution, block level replication, it's below the file system. We don't even know or care how many databases you have. It's just ones and zeros on a disk. So it scales very well for those instances where you have hundreds or even thousands of databases or multiple terabytes of storage. It's not going to increase your overhead at all.
Okay. Let's see. The next question here is related to a trial license of DataKeeper. Is that available? And if so, how do people get a copy?
Yeah, absolutely. Trial licenses, we have 14-day trial keys. You can contact us at the information provided here. And I think, Greg, you might be able to pop up a poll question. So if you want us to get in touch with you, just say, yeah, to the final poll question, and someone will reach out to you and we'll get you a trial copy of DataKeeper.
All right, great. Well, we're just about out of time, so just going to wrap things up. So as Dave mentioned, there's a bunch of contact information to get in touch with SIOS, to download the trial, to take a look at other documentation they have on their website, and also Dave's contact information. So I want to thank Dave for presenting today. There's definitely a lot of great information about Azure and AWS, and also want to thank SIOS for sponsoring today's webcast. To all of our listeners, don't forget to visit the SIOS website to learn more about their offerings. The webcast was recorded, and you'll receive a follow-up email with links to view the archive, and we'll also get a copy of the slides that we can include with the archive as well. Also, please visit mssqltips.com to access all of our free SQL Server resources. Once again, I'm Greg Robidoux from MS SQL Tips. Thank you for attending, and have a great day.